In this video, we're going to discuss the unit tangent vector. So unit tangent vector. So as the name indicates, it's a tangent vector. So if you were to have, say, a curve that looks like this, your tangent vector would be a vector that is tangent. And it's a unit vector. So if we let capital T denote our unit tangent vector, that would mean that the magnitude would be equal to 1. So it's a unit vector, in other words, a vector whose magnitude is 1, and its tangent. So basically all we do is take the velocity vector, which is the tangent vector, and we force it to have magnitude 1. In other words, we normalize it. Let's carefully go through the definition, and then we'll look at an example. So let capital C be a smooth curve. So be a smooth curve represented by a vector valued function, say r, on some interval I. So on an interval I. Then we define the unit tangent vector as follows. So then I'll just say the unit tangent vector. I'll underline it. So unit tangent vector. And the symbol we use is a capital T. This is pretty standard. So T of T. So it's two T's. Use a capital T for the tangent vector, lowercase t for our parameter. At T, so at the value of the parameter T is, and basically what you do is you take your velocity vector. So if r is your position, the derivative of position is velocity. So you take r prime of t, right? That's a velocity vector, and you normalize it. You turn it into a unit vector. So basically you divide by its magnitude. So you do this like this, and now this big T is a unit vector. You might say, well, what if the derivative is 0? It can't be. So I'm going to specify that it's not, but it can't be equal to the 0 vector. And that's because C is a smooth curve. Right? Remember, if it's smooth, that means that this velocity vector cannot be 0. In other words, if you have a smooth curve and r is a vector valued function on that curve, the derivative of r is not 0. So this is because C is smooth. That's what we need to condition that C is smooth, so that the definition makes actual sense. So let's go ahead and do a simple example of finding the unit tangent vector. So let's try this one. We have a vector valued function, r of t, and this is equal to t cubed I hat plus 5t squared j hat. And the value of the parameter here is t equals 2. So we want to find the unit tangent vector when t equals 2. So solution should be pretty easy. So we start by just taking the derivative, right? Because we need that piece there up top. So let's see what the derivative is here. So r prime of t. So to differentiate a vector valued function, you just differentiate each component. So the derivative of t cubed is 3t squared. And then we have the I hat. And the derivative of 5t squared is 10t. And then we have the j hat. So that's our velocity vector, right? If r is a position, r prime is our velocity vector. And now we can construct t of t. So big T of little t, I'll write out the definition. It's r prime of t divided by the magnitude of r prime of t. Okay. Now we could have plugged in the numbers first, but let's just go ahead and write this out. So r prime of t is going to be this top piece here, so I'll write it up here. 3t squared I hat plus 10t j hat. And this is a little sloppy because I'm going to divide this. You're not supposed to divide vectors, right? Really, we're multiplying by a reciprocal here. The magnitude of this thing, right? So it'd be the square root. And then you just square each of these components, right? Let me show the step. It's 3t squared plus 10t squared, right? You square each component, right? You square this guy, and then you square this one, and you take the square root. That's what the magnitude is, right? So this is equal to, this is going to be 3t squared I hat plus 10t j hat over, and then we have the square root. So 3t squared is 9t to the fourth. And because you square the 3 and you square the t squared, so yeah, 9t to the fourth. Then you square the 10, that gives you 100. And you square the t, that gives you t squared. So that's our velocity, that's our unit tangent vector at t. So we want this at t equals 2. So we want big T of 2. So big T of 2. So what's that going to give us? Let's see. Plugging in 2 here, we get 3 times 4. So we get 12 I hat plus, and plugging in 2 here, we get 10 times 2. So we get 20 j hat. Over, and let's see, down here we have 9 times 2 to the fourth plus 100 times 2 squared. Okay, lots of math there. Uh-oh. Okay, so that's where we are. So this is equal to 12 I hat plus 20 j hat over, okay, and let's see, this is 2 to the fourth is 16, so it's 9 times 16. So 9 times 16. So 9 times 6 is 54. You carry the 5, old school. 9 times 1 is 9, 144. So this is 144. And this is 100 times 4. This is 400. So this is 544. Okay, let's keep going. So this is going to be, let's break this up. This is going to be 12 over the square root of 544 I hat plus 20 over the square root of 544 j hat. So that would be our unit tangent vector. You could simplify the square root of 544, I believe. I believe 544 is 16 times 34, and then you just take the square root of each piece. And so you can rewrite this bottom piece as 4 square root 34, but I'll leave it like that. So that's how you find the unit tangent vector. So it's just a vector that's tangent, and it's a unit vector. So I hope this video has been helpful. That's it.